everyone, and welcome to Let's Talk MLOps. My name is Becky, and I'm on a mission to find out the latest trends, challenges, and prospects within machine learning, and with a particular focus on machine learning operations, or MLOps. Throughout this series, I'll be talking to experts within the field who will share their knowledge as well as advice for implementing, monitoring, and scaling successful machine learning practices. Hello, everyone, and welcome. I'm super excited to be joined today by Mikiko Bazeley, who is Head of MLOps at Featureform, as well as a contributing writer for NVIDIA. She's here today to share tips, advice, talk about her experience and her personal journey into MLOps as well. So I'm really excited to get started. Thank you so much for joining, Miki.
Hey, everyone. How's it going?
Awesome. Okay. So, to begin with, as I've been learning over the months, I've noticed that there are lots of different pathways that people can take into MLOps, be it data science or software engineering, there are loads, or DevOps. So I thought it would be nice to start with a bit about your personal journey and the pathway that you've taken.
Yeah, absolutely. So I think for me, like when I think about my career, I almost think about it in terms of like acts or stages. So the first part of my career, so I had graduated from UC San Diego in anthropology and economics. I had practically kind of like failed my way to graduation. So I took 5 years to do undergrad or uni. Um, and initially I'd gone in as a biomedical engineering pre-med major, but that kind of didn't work out. So essentially I just took courses that seemed interesting in terms of how humans operated, how humans think, especially in a group, their relationship to technology, so just took those classes just to graduate. So, I graduated in 2013. First few years after that was working for various startups on like the growth and business and product side, really kind of understanding the sales to like revenue sort of chain within companies, which I feel is really important. And for companies of like very different industries. And that first act was where I started transitioning like on my way to more of the data science machine learning route. Was working as a data analyst for companies like Autodesk. I was kind of like a hybrid data analyst. I also worked for an Israeli startup called WalkMe, where I was a sales revenue analyst as well. Worked for the largest residential solar company in the US, Sunrun, as an analyst there. And then eventually, what I realized was, hey, there is this like power to use data science machine learning to go beyond the analytics, right? You're mostly describing the historic, what has happened. You're trying to attribute some kind of reasoning or understanding of the why. But with data science machine learning, I realized that I could, one with like understanding good like experimentation design fundamentals, try to get a little bit closer to like causal reasoning. And then with the machine learning side, of course, the fun part was in predicting models. So I worked as a data scientist for a few companies, partially Autodesk on their 3D construction software side, and then Teladoc, which was maybe still is one of the largest like telehealth medicine providers in the US. But a problem that I ran into repeatedly, and I feel like this is really a cornerstone for how people get into MLOps, was I'd gone through, I didn't have traditional schooling in data science and machine learning. Aside from my 5-year undergrad degree, I have not done any formal education since then. I was running into a problem I was running into as a data scientist was, how do I get my model out of the Jupyter notebook and then get it in front of key stakeholders, whether they're on the product side, whether they're internal users like marketing product, whether they were external users, for example, people using the application that's embedded in, or that predictions are being served through. I had no idea how to actually do that, and the team that I was on at Teladoc the engineering resources were kind of, I don't want to say they were slim, but they were really focused on the main products and services, which was, for example, the diabetes monitor, the hypertension cuff that people would use to like measure their blood pressure. So they were really focused on like the hardware. They were focused on the software. A lot of times on the data side because we were subject to not GDPR, but we were subject to HIPAA. So it was a lot of like bootstrapping and having to try to kind of figure out this like very, very rough process. And I kind of realized that was like the bottleneck, at least in terms of getting value out of data science in large part. Part of the value in data science is the insights, it's the research, it's doing things properly. But the other, I think, value also is when you expose and you scale out machine learning products for a large number of users. And that's really dependent on your deploying and serving operations, like how good those are. So that's how I started making the pivot much like towards MLOps. I realized I was much more interested in the engineering side and the like, how do we, like the saying, cattle, not pets, how do we, if we were to treat all these models as like kind of black boxes or pipelines, how could we create a platform and how could we structure best practices and the human and technology component such that people can, develop delightful products easily without having to think about, for example, like Kubernetes or Prometheus or Grafana or any of these other or Jenkins or CI/CD. Like how can they kind of just do what they're best suited to or what they want to be doing more of without going into like low level stuff. So that's kind of my story of how I got into it. I do feel like while there are a lot of paths into data science, I do think for the most part, when people move into MLOps, I notice that it is usually either from a data science perspective or they were a DevOps or a platform engineer. And so their challenges are really like, is really having them wrap their head around like the machine learning lifecycle. Whereas for all data science, it's like learning like, oh shoot, now you have to learn like some best practices around like DevOps and platform engineering or things that are just sort of like understood in like the SRE side of the world around like monitoring and containerization and all that.
Were they the biggest challenges that you found when you pivoted?
Absolutely. Yeah. Yeah, because I think and you see this too, for example, when on the one hand, it's fantastic that there are so many opportunities for people to share their learnings. But as we kind of saw during the pandemic, just because things are easy to do, a lot of times that also means they're maybe not done well. So all these models and all these analyses that were coming out to try to predict COVID, many of them suffered from just really, I don't want to say like obvious things, but they suffered from data leakage. They suffered from lack of proper experimental design, especially because they were mostly being done on like historic data. Conflating variables weren't being isolated and identified. So a lot of those things that data scientists look at and go like, oh, that's like really basic stuff. I was going into MLOps from a distinctly like not software engineering background.
Yeah.
And so a lot of things that were challenging for me was like, for example, like there's developing applications in containers and then there is orchestrating like containers. And then, so that was like one challenge. Another challenge was really understanding the different kind of patterns that mall predictions could be served. Besides the batch pattern, but for example, like how to create a REST API and set someone up so that you can have a model prediction go through it. How do what's the right level of like testing for data and models? So there's a lot of things that like I kind of had to pick up that for probably a lot of software engineers, they kind of learn their first 3 to 4 years of working. But I enjoy it a lot. I think I think there's a lot of value, especially in like the MLOps like engineer role and the MLOps discipline for sure.
I mean, they're still relatively new terms, right? Like, would you say sort of
Yeah.
the out and out MLOps engineer, kind of not more than 3, maybe even 2 years, would you say that you've seen these roles and these positions coming up?
Yeah, absolutely. And it was interesting because for a while, we had the data scientist and then we had the ML engineer, which
Mm,
is almost like the full stack data scientist.
yeah.
And then we had this new role like the MLOps engineer come out. And I think a lot of people argue that MLOps is just DevOps. I do think I don't know if I quite agree with that sentiment because there are things that, for example, as a DevOps engineer, if you are working in a company or industry or product where ML usage is very minimal, you're not really going to have to change your pattern of like software development significantly. Whereas if you are an MLOps engineer who is working with very heavy like ML products, you do have to like think and do things a little bit differently, especially once you start getting into the experimentation development side of the house. But it was interesting because I do feel like in some companies, the ML engineer role, oftentimes it's I think a lot of times it's almost used as a bridge
Mm-hmm.
for a lack of great like practices and having an ML platform. And so you kind of have these like ML engineers who are these full stack data scientists where they're sort of just like recreating pipelines over and over and their components. And I feel like that is sometimes that's like a stage in maturity
Mm-hmm.
where a company has to like deploy a lot of models to then kind of really understand like what their particular requirements are. But sometimes that's also an anti-pattern where I think sometimes companies they don't really invest in developing the MLOps or in growing the MLOps culture in their company and then investing in a proper ML platform. Because otherwise, a lot of data scientists, I mean, some data scientists are ML engineers, like they like the software side too.
Mm.
But there's plenty who they are happy if all they could do is just identify like what are some key interesting questions. Go do the research. Could be through papers, could be through talking to other data scientists, it could be um, through meetups, developing these models, understanding how they should be tested, understanding what are some of the risks or trade-offs, for example,
Mm.
and then creating that product, working with their engineering partners, and then like moving ahead. Plenty of data scientists who don't want to do infrastructure.
I suppose it varies. It will vary a lot depending, but also
Yeah.
I suppose that kind of leads me to where data ops comes into play because something you mentioned to me before is you have an interest in the unification of MLOps with data ops. So what are your thoughts on that?
Yeah, and it's pretty fascinating because I feel like there's going to be some there's going to be some kind of intersection between data ops and MLOps. Um, an area that I sort of like look at and think about a lot is when you talk to data engineers and you ask them who their key stakeholders are. A lot of times they'll say it is the business side, it's product side, it's analysts, and it's data scientists and machine learning engineers. And I really question the I don't say value for machine learning, but a lot of times, like data science machine learning engineers, they know their domain best. For example, um, I am not going to go tell I'm not going to go tell a an NLP engineer or researcher, hey, like I think this is how you need to structure your model or pipeline or your system even. Um, this is how these are the algorithms you should use. These are the metrics you care about. I know a little bit to understand the implication on like the infrastructure side, like how can I work with you, the expert in your domain, to create a delightful interface that hopefully could be also generalized to the time series expert. But I wouldn't go so far as say, like, I know exactly the features you need to be using. I know exactly how you should be doing your work. And I think that's where I think a lot about that intersection between data ops and MLOps, because MLOps is all about um, the development and productionization and deployment of machine learning artifacts, and data is a huge part of it.
Mm-hmm.
But you can hypothetically have machine learning with small data. That was an article that was written by that came out of Mother Duck about how big data is dead. Don't know if I quite agree with that statement, but small data has been incredibly relevant for a very long period of time. So not only are data science and machine learning engineers doing their own transformations on top of the data, a lot of data science and machine learning engineers also they also work with small data. You don't always have to work with big data sets. So I think they're people, especially on the data ops and the MLOps side, I think they think there's this close alignment between data ops and MLOps. And I feel like right now, at least with all the existing tools and interfaces, I would disagree with that. I think there are gaps between those two areas. And I think they're going to be increasingly important, especially because I think one of the most interesting things that we've seen out of like the most recent generative AI trends is everyone wants to create ML products. It really doesn't matter what your title is. It doesn't matter if you're an analyst. It doesn't matter if you're a data scientist, you're a product manager, you're an account executive in Idaho. Everyone wants to dream and be creative and ideate, and then eventually get to like some kind of outcome. And I don't see a lot of the MLOps tools, I think right now are not sufficient for data products, but I also don't see a lot of data products being really sufficient for like ML products. And I think with companies, especially like we've seen all these layoffs happening, a lot of companies are being kind of increasingly cautious about their spending or about their tooling. And I think right now, at least with the current tooling space, they would have to almost pick if they're a data company or if they're an ML company. And I really feel like there's such a tight relationship between like having really great data that is like curated and that is enriched with your particular industry or domains, um, uh, first party data, as well as having ML products that are very unique and competitive and differentiated. So I'd be curious to see like if those like start kind of coming together a bit closer.
Yeah, because I mean, as you know, I'm not an engineer at all, but I suppose it might sound really simple, but is there the possibility to create products or tools which can work for both and could unify them, even if they're not already at a point where it's possible? Do you think that could be in the future? And if it is on the cards in the future, could that be beneficial? You know, you said lots of companies trying to cut back and maybe save money. Could that be a positive thing?
I think so. And at least like I feel like there are I actually think so. And I think there are definitely some interesting there's been some potential like opportunities for integrations in like the existing like data and ML ecosystem that I would be really excited to see. I know over at Featureform, for example, we're a virtual feature store company. We've been asked a couple times, like, hey, do you offer? How have you considered integrations with XYZ category in like the data ops space? And so we're looking at it. We're thinking about it because we recognize that hey, a lot of like data scientists, especially with kind of like our open source offering, we kind of sit at that intersection between the data set and the model. Or even like the model and predictions. So we think about that a lot. And I do think that we could, I feel like something that has been a little bit lost in the MLOps side is the data scientist as the original customer and key stakeholder of MLOps tooling. I feel like right now, some folk, like a lot of folks offer different integrations, but we're not always thinking about the holistic experiences of like the data scientists going from end to end. A lot of times they do kind of have to like patch together sort of like different tooling. And I think we could be doing better like as an ecosystem in being a little bit more opinionated in while still offering flexibility, having better interfaces,
Mm.
having simpler APIs, thinking more about how do we sort of solve problems at the workflow layer as opposed to like the underlying compute and like the hardware layer.
Cool. Okay. Yeah. I suppose, and that's kind of looking to some changes that could happen in the present going into the future. What about looking back slightly into the past? Let's say, how would you say, what changes have you seen with MLOps in the last sort of 5 to 10 years?
Yeah, absolutely. And it's fascinating how quickly the tooling space develops. But sometimes I think the experience I've had recently actually is realizing that not only was my perception of the MLOps ecosystem maybe not up to date, but a lot of folks who work in the space, um, especially I think like at this point, like everyone's seen Matt Turk's Mad Landscape with the hundreds of logos on that site, in that PDF, where you have to kind of zoom in, but like when you have it zoomed out, every single one is almost like practically like a couple pixels big.
Yeah.
That's like very overwhelming to most folks. And the thing that I try to convey is like, hey, um, not all those tools are equal and they don't operate at the same layers. So I think most people, they mark the beginning of MLOps with the first paper published by Scully and friends over at Google, which was the uh, high interest credit card debt of machine learning. Basically, it's the paper that has that famous diagram of like, like ML code and then all the other boxes around it with all these kind of um, tools and platforms and infrastructure that is needed to kind of support even like a single or even 10 like ML models. And that was about, I think, 2015, I want to say. So I
Okay.
would say like that was like the first wave of MLOps tools kind of was like 2015 to 2017, 2018. We had a lot of things like that were published. For example, we had Michelangelo. Um, there's a number of frameworks. So this V1 set of tools, a lot of times they were developed in-house at these like cutting edge startups or you know, I don't say early stage, they were like late stage startups who were kind of solving very, very challenging problems with data. For example, they were solving challenging problems around like streaming data or real-time inference and prediction. Um, so they create a lot of these in-house frameworks. At that time, companies like Google and Amazon, they weren't offering anything close to what they needed. So either it would have been incredibly expensive to buy the offering from Google and AWS and Azure, or those companies just weren't offering tools. So these tech companies like Uber, Lyft, Twitter, a number of others, they started publishing papers, potentially releasing and open sourcing their internal frameworks. And these are really cool, but a lot of times they were very tightly coupled to like the underlying infrastructure choices. They weren't really always meant to be released as like an open source library. Zipline is another one. MLflow was released by Databricks in 2018. We also had Apple published Overton, which is in 2019. So that was like I say the first cycle, very specialized, cutting edge, tightly coupled solutions. I'd say the next cycle was the all-in like end-to-end platform plays, where companies they look at it and they said, okay, yeah, like there is a lot of tooling choicing that's going on. So why don't we give people like an all-in solution? AWS started this off with SageMaker in 2017. Google was really late. They released Vertex AI in 2021, but they had like a notebook offering called AI Platform years before that, and they started releasing TPUs in 2018. So that was cycle two, where whether you're buying into Google, Facebook, or sorry, Google, Amazon, Azure, or whether you were buying into like one of these startups that were more like the end-to-end MLOps platform, that still wasn't like great, because on the one hand, you know, with the first cycle, you're still patching together a lot of tools for which the ecosystem was not there yet.
Yeah.
And they were rough and buggy. I think a lot of people remember the early years of using Spark. It was better than Hadoop, but you know, by a lot, but still not quite there.
Yeah.
V2 was just, it was even tighter coupling. But it also meant that as a business, you couldn't swap out, for example, if you wanted to use Cassandra or MongoDB or Redis to serve your predictions, a lot of times you couldn't do that. Or let's say, for example, you wanted to swap out your data warehouse. You couldn't do that either, hypothetically, right? So now, currently though, I think we're in a different cycle, the V3 cycle of MLOps. So the hype is kind of worn down, but now we have so many different options of tooling for MLOps. I think in some ways we are more pragmatic, i.e., a lot of MLOps tools right now, they're not trying to go for the end-to-end play. They're also trying to essentially solve a different class of problem than like the V1, V2 companies were, where it's more on like the how do we do ML, the how do we, for example, in Featureform's case, how do we support like the feature engineering stage and feature serving for data scientists as a virtual feature store. But that's where like you're seeing companies, for example, like ZenML, Featureform, Flight, Kubeflow, Metaflow, a lot of those are just, they're working at like the highest level or the highest layer of the MLOps stack of trying to kind of unify the different stages.
Okay. And is that the best way to organize them? Do you think you really need something, if you've got so many different tools, organizing them in a unified space is the best way to go?
I think, yeah, I think that's a great question. I guess the question we play around with all the time is, do we think there's ever going to be like a modern MLOps stack? Similar to the way there was a modern data stack. And I really don't think so personally. I think most people I've talked to also agree they don't think there's going to be an MLOps stack, mainly because there's a lot more, I don't want to say there's a lot more variety in ML systems than there are data systems. That's not quite what I want. That's not quite where I want to get at. But in terms of so first off, in terms of requirements for like ML products, the design for a recommendation system is significantly different from the design of, for example, a forecasting system or an inventory optimization model. A lot of these, they have very unique kind of differences. It does impact the data layer, absolutely. But I also think that companies have so many different combinations of these requirements, and they are very legitimate, right? So you would expect, to a certain degree, an e-commerce shop that is serving hundreds of thousands of customers is going to have a much different set of requirements than, for example, a small mom and pop shop that is maybe using, for example, a generative AI tool to write email copy, or for example, a medical system provider where maybe they have a digital health or a telehealth offering. But like maybe for them, they're much more concerned they're less concerned about latency, and they're much more concerned about security, about user access, about governance, things like that. So all those requirements are different. They're very unique. They're very legitimate. So I do think companies should kind of design to where they are and where they're going to be. In terms of like organizing, I think we can do the way I would kind of, when I'm like working with startups or working with folks who they need advice on like how to design their ML systems, what I try to do is first try to kind of map it to a matrix of the first kind of axis, or the first axis is kind of the stage of the ML life cycle. And specifically the first stage is like what I call data set engineering, as opposed to like data engineering. So with data set engineering, you might be working on a couple different data sets as a data scientist, but you're not necessarily working with 100 different like storage systems or what have you. You're analyzing it, you're cleaning it. The second stage is always model experimentation and training. Third is deployment and serving, and the fourth is like monitoring and evaluation. So aligning it from that first axis, and the second axis is like the degree of abstraction. So for example, the first layer, or like layer 0, is like the hardware. And right now, at least most companies, really companies that are providing that are like Azure, GCP, AWS, with like S3, with BigQuery, with Cosmos DB, you name it. So they're essentially like providing the compute storage. Layer 1 is like the frameworks. So for example, you could go with like a serverless GPU like Banana or Modal, or you could go with, for example, like Kubernetes. Kubernetes is a compute framework, effectively. Same with Ray. You're essentially, and you can use them both together, hypothetically. But essentially, you're just kind of like orchestrating like VMs, you're orchestrating containers, right? Then you have like the next level above, which is like services. So that includes Spark, that includes Bento ML, YLogs. Layer above that is like the workflows. So we have Featureform, where we work on we're a virtual feature store company. So we're like, straight in like that first like stage of the ML lifecycle. Then you have like Comet, weights and biases, ML flow for model experimentation and training. You have like, for example, Yatai from Bento ML for serving. And then like the top layer is essentially kind of like the orchestrators of orchestrators, where they're trying to provide the like unified platform experience, but without necessarily locking people in to like all the layers below that. So it's essentially just providing like abstraction on abstraction, ideally so that, whether you're a data scientist or a data engineer or an MLOps engineer, you're really kind of, you're thinking about your day-to-day tasks kind of like at the right level. So as a data scientist, you're not worried about Kubernetes. As an MLOps engineer, like you definitely should be worried about Kubernetes. You should be thinking about your compute frameworks. But maybe, for example, you're working with your IT SRE team to think about like the hardware choices, or maybe even the hardware choices are being decided by both like MLOps engineers and data engineers, right? So that's, I think, ideally the way people should think about it. And from there, like to do kind of ML properly, you need to have coverage over all of that. But you can, depending on if you choose the right abstraction, you can kind of make the decisions going from bottom up or even like figuring out what your most immediate bottleneck and pain point is, and then kind of deciding out from there, and like just kind of expanding your offering.
Okay, awesome. Thank you. That's really interesting. And yourself as a leader within MLOps, do you have any specific tips for organizing the MLOps teams?
Yeah, so yeah, it's a really great question, and it really depends on like the stage and the maturity of the company. So I think if you're like an early stage startup,
Yeah.
um, your goal should ultimately be get someone with strong like software engineering skills, with just enough understanding of like cloud that they could either work with your existing stack or build something out. If especially actually if you're like the very first, like, for one thing, I don't think you should have an MLOps engineer if you're like very, very early stage. You should have like a full stack like engineer who can do like machine learning and data. Definitely, I would actually pick like a data engineer first, almost before you do an MLOps engineer. But I would say like hire like a data scientist or an ML engineer with like really strong suite skills, and just get your first couple models out. And to get your first couple models out, I would rely on like tried and true like patterns and methodology. Um, so like you don't need streaming early on, unless like your product is very specifically streaming, like it's a gaming or whatever product. Uh, Most people can get away with like either doing a batch like ML model pipeline, or even doing a live service kind of style where you train a model and then you have like a dot predict function. You can launch it using like a serverless GPU offering, or even like as a container. You plop it right behind a REST API, and then you could have like real time inference. You don't need to have real time training, right? I think that is a very fine sort of way to go. Like, don't worry about like retraining. And honestly, they can use the simplest tools possible. So maybe they use like whatever data storage or data warehouse system that their company is using, or maybe they use DuckDB. They use Featureform as like a feature store on top of those. Maybe they, for example, just Google's like TPUs, and then they experiment track using weights and biases or Comet. Then maybe they deploy a model with like Bento, um, and then they use whatever like CI/CD tool that like their existing engineering team is using. If they're like, for example, if they're beyond that, like they're not just a solo data scientist starting out on a new team, but they're like sort of the SMB midsize, I think that's where you can start thinking about standardization and practice. And then at that point, you can start thinking like, okay, what decisions do we kind of need to make at like the services level? And then do we want to start solving the organizational aspect of it? I.e., do we need like an orchestrator, orchestrators? And how do we start like packaging things up so that we have, like, for example, Spotify calls it the golden path, i.e., there's like kind of predetermined paths that data scientists or SWEs or like ML engineers can go down to like develop like ML products. I think I'd say around the mid-size level is when companies should really start thinking about like, okay, how do we start creating like a platform that unifies these different components? But before that, they should just really be like shipping models, and it should be like the simplest patterns possible, and just doing whatever they can to make the data scientists productive. And a lot of times that means like keeping the tech stack very, very lean. So you're really only invested in like the data set engineering or analysis and feature engineering, as well as like the experimentation and training for models.
Okay, awesome. Thank you. I think we've only got time left for one question. So I think it would be nice just to end, and this can be related to MLOps or just even related to AI in general, if you like. But what do you think is the most exciting thing happening right now? You know, what are you feeling really excited by in AI or MLOps?
Yeah, so oddly enough, the two things I'm kind of excited for is like one, the MLOps hype is, I don't want to say it's died down, uh, but it's not as hyped as it used to be, and I think that's actually a really good thing because what that means is that a lot of companies that are existing now, or a lot of the open source projects that exist now, we can really kind of focus in on really kind of like unifying and like solving like the hard problems for data science productivity. So, and not just data scientists too. Like I think like everyone wants to build ML products, whether or not they articulate it or they call it that. And so now I think is the time for a lot of us folks on the ML side where we can really start digging in deep and kind of like focusing in on the stages and problems that like I don't say that really matter, but have yet to be solved. I think the other second part I'm really kind of interested in is so like Gen AI I think is really kind of interesting. For me, like my interest in it is to a certain degree from a very pragmatic, boring, how will this impact like system design for both machine learning platforms and both for teams building ML products. So when I was at MailChimp, I want to say I joined Featureform last October. So I was at MailChimp for a year and some change before that. I was really quite impressed with the kinds of products and features our data scientists were developing. But I had also noticed too that there were some, I don't say challenges, but there were kind of new innovations or new practices that we need to develop on the platform side in order to enable those to happen. So for me, I'm like very, very excited about always solving like new challenges, especially with how to support like innovative products. And even more excited for kind of the opportunity to build in public and like share those learnings. But yeah, it's going to be interesting for sure. We'll have to see like what the next like year brings up. I know the last 2 weeks has just been absolutely crazy with like the advances that have come out, and also with the adoption of those advances by most of the public, many of whom, for example, they're also not software engineers. They're not necessarily involved in tech other than being consumers. And so watching them use these technologies to like build new products is both fascinating and also very scary.
Yeah, definitely equally both, I think, but really exciting. Awesome. I'm really sorry. I think that's all we've got time for today. But honestly, Mickey, thank you so much for, all the examples you've given and the tips, from different perspectives and different angles. That's been amazing. And thank you to everyone watching as well. I really hope you enjoyed today's episode and hope to see you again soon. Bye-bye. Let's end with a little bit about Logic. At Logic, we recruit specifically within the machine learning engineering and research fields in the UK, Canada, and the US. We pride ourselves on our innovative, community-led approach and having a deep knowledge and understanding of the roles that we recruit for. That's one of the reasons why I've started this podcast. If you're looking for your next professional challenge, or on the other hand, you might be an organization looking to expand your machine learning team, then please feel free to connect with me on LinkedIn and send me a message. Alternatively, you can send me an email to becky@logic.com. Let's set up a call for a chat, or we can meet in person for a coffee.